Hello my dear students, today I am going to start a lecture about your biogas plant, that is size and site selection of a biogas plant. Earlier we have discussed about the parameters which is effect on the biogas generation. Okay, today will be the after that there will be site selection and size selection of a biogas plant. So we will be discussing about this topic briefly. Okay, this topic is not too much difficult here. If you go through these materials of this one, you will easily understand. Okay, so just briefly I will discuss about this one. Here before that size of a biogas plant, what is sizing then? So basically sizing is your overall size of the digester and all, and it's basically depend on three parameters. Daily feeding, that means daily raw materials of your cow dung or any other cattle manure, daily feeding rate or daily feeding intensity. Another most important parameter is retention time, that means hydraulic retention time also, that duration after that feeding up to final, up to what days that gas generation will be taken place. So normally the standard retention time of any biogas plant is your 30 to 45 days. Somehow in biogas plant it may extend up to 60 days, that we have already discussed in the parameter section. Okay, another parameter is retention time. The last parameter is a digester volume. Okay, here digester volume, depending on the digester volume your sizing will be vary. So here also, here depending on the raw materials available, that means cow dung, your daily feeding will be vary, and as well as your sizing of the biogas plant also vary. Even if the size is different, the retention time is also different. For a smaller biogas plant, retention time will be lower. For bigger plant, that means bigger raw materials is required, the bigger retention time will be there. So that is why these are the major parameters which is directly relation have the direct relation with the sizing. Okay, here you will see the biogas plant size is depend on the daily average feeding. We already know that feeding is very much essential in daily basis as a particular time. Okay, that is why the biogas plant size is depend on the average daily feed stock or feeding size, and also expected hydraulic retention time, that means your up to your 30 to 45 days. So that parameter, that duration of time is directly depend on the your biogas plant size. Another is a capacity. So what is capacity? Capacity of a plant should be designed based on the availability of the raw materials. If raw materials is low, so the capacity will be low. If raw materials is available, more raw materials is there, so capacity will be higher. So that is also depend on the sizing. Also capacity of a plant indicates that quantity of daily gas generation. Okay, the depending on the feeding, depending on the retention time, your gas generation will be vary. If less feeding or daily irregular feeding is there, so there will be a chances of variation in the gas production, that gas will not produce up to the mark, up to the expectation. Okay, see the next one, that based on the study, that may research data, as we know that slurry generation is happened due to 1:1 ratio of cow dung and water. Okay, so if for example 1 kg of cow dung is mixed with equal amount of water, that is ratio is 1:1, under the anaerobic condition it will produces 0.04 meter cube, or in liters it is 40 liters of biogas. Okay, this is standard one. Try to remember this figure, very much important here. Okay, for example, taking one example, because why their example is given, last previous year one question was like this: if any farmer have the 100 cows and that much is the daily generation of biogas cow dung, so give any suggestion of that farmer which renewables alternative source of energy that farmers can adopt. Here cow dung is mentioning, that is why obviously the technology will be your biogas plant. That is why the simple example was given here, that if a cow daily average yield is 10 kg, okay, and that particular house or farmer have 3 cows, so what will be the expected gas generation from the biogas plant? That means based on that 3 cows every day 10 kg cow dung, what will be the design of the biogas size? Okay, here you the numerical, you see simple numerical, one cow will yield an average of 10 kg cow dung during every day. If the farmer have 3 cows, So objective is to calculate the capacity of the plant. Here you see this, 3 cow into 10 kg cow per day is equal to 30 kg cow dung per day. Since 1 kg cow dung will yield 0.4 meter cube or 40 liters of biogas, then what will be the total biogas generation if 30 kg is the daily generation of cow dung? So 30 kg will produce here 30 into 40, 1200 liters. That means 1.2 meter cube of the gas. Okay, so that farmers can go for that construction up to your 1 meter cube. That 0.2, there may be something losses. So 1 meter cube design of that particular biogas plant is sufficient if that farmers have 3 cows. So if the number of cows is increasing, your daily feeding, daily raw materials is increasing, so based on this you can design the bigger size one. Okay, this is smaller one. Okay, go to the next slide. Here the reverse case. Earlier it was that if the raw materials is that much, what will be the plant size? Now if you want to design a 1 meter cube biogas per day, 1 meter cube gas generation of a biogas plant per day, what will be, how much quantity of cow dung is required every day? Reverse case, similarly we know that 1 kg of cow dung, again 1 kg of cow dung, 1 kg of cow dung with equal quantity of water, that is 1:1 ratio under anaerobic condition, to produce how much? 0.0 meter cube. So now our purpose is to produce 1 meter cube gas. Okay, so since we know that 1 meter cube, 1 kg of cow dung is produces 0.4 meter cube. So our reverse case, 0.04 meter cube biogas can produce by 1 kg of cow dung. Therefore 1 meter cube of biogas quantity of cow dung required, that 1 divided by 0.04 meter cube per kg of cow dung. So that is your 25 kg of cow dung. That means if you have 25 kg of cow dung every day, then you can go for a plant which having 1 meter cube, which that plant gives the 1 meter cube biogas generation per day. Okay, that reverse case you can calculate. Okay, fine. Here you see the daily feeding rate or your plant size. First case, you see plant is of 1 meter cube. First one is a 1 meter cube. Your daily dung required is 25 kg. Water is similar, 25, 1:1 ratio, 1:1 ratio. If it is 2 meter cube, 50, water is 50. If it is 3, then your daily cow dung is 75, and also similar ways. Okay, these are the standard research data or experimental data. Okay, here biogas plant is given there because in next slide we will be discussing about the size of the digester, that digester part. So you already know digester holder and dome, digester also called dome. Okay, go to the next slide. Here here size of the digester basically it depends on 2 parameters. One is your length of the retention time. What will be the total duration of the retention time? How much days required to complete digestion to produce a gas. Okay, and also the amount of fermented slurry. Here you see 2 parameters. One is your length, another is your amount. That means one is your liter per day, that is amount of fermentation, another is your number of days. The amount of fermentation slurry consists of feed material, whatever, that is cattle whatever, and animal manure, piggery manure, and mixing water, these 2 things. So again another example, if 25 kg of cow dung and 25 liter, 1:1, again that slurry formation will be 50 liter fermentation slurry. And what will be that digested volume with this 50 liter dairy slurry? The digested volume is calculated by this formula, that volume is daily feed, liter per day, and retention time, that is in days. Okay, here day in day cancel, obviously your liter will be there. Assuming that retention time is 40 days, normally 30 to 45 days is standard, so here assumption is 40 days. Then the digester volume can be calculated like this, the 50 liter per day that we got 50 liter fermentation slurry into 40 days. So it will be a 2000 liter, that means 2 meter cube your size of the digester. This way you can find the digester size. Fine. If you go to the numerical, simple numerical here, you will easily understand. Okay. Fine. Next, site selection. This earlier slide up to this, there is a size of the digester and size of the biogas plant. Now site selection. So every time while going for construction of biogas plant, you have to be give more importance of the location or area surrounded by the biogas plant. So first parameter is your distance. The distance between the plant and the site of the gas consumption. That's two things. Gas consumption should be less in order to achieve economy in pumping and minimizing the gas leakage. See, the plant generation is one place, if the site gas consumption is in different place, if this is too far away, so there is a chances of excess cost of this piping and all, and there is chances of leakage as well. Number of joining, number of bend will be there, so that can also causes the overall losses in the gas generation. Okay, for plant of 2 meter cube, that's an example of this one. So optimum distance is recommended here 10 meter. Okay. Okay, another is your to make plant easier to operate and avoid wastage of raw materials, especially the dung manure. Plant must be as close as possible to the cattle shed. Okay, so here also the distance should be as much as low, because here also minimizing the cost, also that easy to maintain. Here there is a unnecessary wastage of raw materials also minimize. Okay, this can be achieved. So that is distance is another factor here. Another, open space. Remember that we also know that biogas generation optimum temperature is required within the structure. If there is sudden decrease of temperature, there will be losses of biogas generation. If there is a increase in temperature, there is also a sudden decreases in gas temperature, the gas generation. Here, that is why that whatever the construction of biogas plant should be in a open space. There should not be any obstruction, there should not be any shadow, there should not be any barrier nearby the biogas plant. So better to avoid damp and cool place. Damp, or that means shadow place. Okay, that should be avoided. Next parameter is your water table. So water table is there. So the plant is normally constructed where? In underground, for easy charging the feed. Unloading slurry requires less labor here also. So in this case, the care should be taken to prevent seepage of water, and plant should not be constructed if the water table more than 10 feet. Okay, so there should be some measurement here. It should not be more than 10 feet. Okay, next is a distance from wells. So nearby the construction of biogas plant, there should not be well. Okay, because it can causes some seepage from the your well to the biogas plant also. Hence a minimum of 15 meters should be maintained from the wells. Also it can be seepage to the well or well to the biogas plant, that can be feasible. That is why nearby the biogas plant there should not be any well. Okay, next parameter is your seasonal runoff. In the during the rainy season or monsoon season, there will be huge amount of rainfall, so it can causes a excess amount of runoff which can flow over the biogas plant. So that should not be allowed. Okay, because it can also create a excess amount of water drainage to the biogas plant, which can directly degrade the quantity of gas generation. So that is a proper care has to be taken care to prevent the interference of runoff during monsoon. Okay, so if that sufficient, if the runoff is sufficient or more runoff is generating, there is chances of more runoff generation. So make a provision for barns or any drainage system nearby the construction, that can be allowed. Okay, next is your space requirement. Nearby the biogas plant generation, biogas plant, the sufficient space must be available for day-to-day operation. Okay, as a guideline, the standard dimension is 10 to 12 meter square area is needed for 1 meter cube gas generation. Okay, that means that biogas plant area, this biogas plant is a free space. There should not be any obstruction within the biogas generation. That within the 10 meter square area, that size is site is totally free of obstruction. Okay. Okay, next see this availability of the water. Since we know that your slurry formation, we require 1:1. Whatever the slurry, that much amount of your water is required. But here, that is why nearby the biogas plant, throughout the year there is availability of water is very much important here. Also in this slurry, we in this cow dung, we know that 80 to 90% your solid material. That solid material can be reduced up to 7 to 9%, okay, by the mixing of water with the cow dung. That is why water is very much essential component here. The whatever you are going to construct in a biogas plant, that availability of water is required throughout the year. Okay, next is your elevation. That means whatever biogas plant, it should be a somehow in a higher elevation side. That means it should not be any lower elevation which can causes water logging. So to avoid water logging, that biogas plant should be somehow in higher elevation side. Okay, this also ensures free flow of slurry from the overflow outlet to the composite side. If it is higher side, so there is easily a free flow of slurry, okay, to the composite side. Next parameter is your these are the major parameters. Some easy other maintenance purposes as well, which is also available for biogas plant generation. That is, site should be easy, site should be your easy construction works, and minimum construction cost is there. So whatever construction, because it is a rural area, so farmers are mainly engaged with this, so cost should not be higher. And also the easy operation, maintenance activities, feeding, use of main gas valve, all these things should be easily handled, and there should not be any gas leakage. Okay, these are should be provided. Also the site should be guaranteed plant safety. Okay, plant safety is very much important here. There should not be any damage within in between the air, in between the gas generation. Okay, next is your the site should be at a sufficient distance from the trees to avoid damage to the digester from the roots. So if it is a bigger tree, tall tree, there is chances of root climbing to the nearby to the biogas plant, which can also damage to the construction as well. Okay, so these are the parameters. Now last parameter is location. These are the site. So where should be the your construction? The biogas plant should not be located further than 5 meters from the field. That means it's always near to the field, because your slurry after gas generation, which can directly used in the farmers, also that digested slurry comes out, which also directly used in the farms. So that is why the biogas plant is recommended that biogas plant should be nearer to the farm and should not be more than 5 meter. And digester chamber must be in open area, that I have already told, and should not be near any water source. There is also causes a seepage, also the pollution as well. The plant should also be situated on the slope. There is some slope is there, not on the lowland. It's always in the higher side, but there is some slope is there. Excess manure from the expansion should flow into the farmer's field. That means digested slurry directly farmer's field, or to the storage tank, but not directly to the any water bodies such as water, rivers, or any other wells that can also cause a pollution. Okay, so up to this your site selection, size, your location of biogas plant is covered. If you have any doubts or any queries, you can ask me in your Google Classroom section or directly in WhatsApp. You can discuss in phone call as well. Okay, thank you.